Okay, one final try at solving equations with fractions to make our lives easier and to hopefully streamline our process. Let's start with an example like 4 over 5x minus 2 over 3x minus a half. And this time it equals 0, but it could equal anything. We've seen that before. All right, so I'm going to start off kind of similarly to the way that we did last time and look at the denominators, with the idea that I want to be able to find out the LCD, or the LCM if you prefer. So I have 5, 3, and 2. So their prime factorization, I actually made our life a little easy here because 5, 3, and 2 are all primes. So their prime factorization is just themselves individually. And if I want to find the LCD, I multiply them all together because each factor occurs only once, and it occurs in the prime factorization of itself, if you want. So 2 times 3 times 5 is 30, I believe. Okay, but this time, rather than figuring out what I would need to multiply by in order to change the fractions over to equivalence with a common denominator, this time what I want to do is just multiply the whole entire equation by the LCD. So I'm just writing this all out so that we can see what happens. This is because this is my preferred method of working with this. Again, as we have seen so many times in this class, there are multiple approaches to most everything that we do in mathematics. And so long as we follow all of the sort of math rules, we're not going to get in trouble if we use one method over another. Okay, so I multiplied this whole thing by 30. And it's important that I multiply the whole thing because I want to make sure that I get both the left and the right side to keep this equation equal and balanced. But I've done that. I put brackets around the whole thing, which means the whole thing gets multiplied by 30. And so my first step to solve this would be to remove the parentheses by distributing the 30 to everything inside. Like I said, I'd usually draw little arrows to remind myself that it's 30 times each of these guys. So it's 30 times 4/5 x minus 30 times 2/3 x minus 30 times 1/2, and that equals 30 times 0, which looks like a mess. But let's see what happens. I could look at it like this. 30 times, well, let's go over here. 30 times 4/5 is the same thing, or that's equal to 30 over 1 times 4/5. And really what happens is, well, there's a 5 in both 30 and 5. And since they're on opposite sides of the fraction from each other, I can simplify those down. So 5 goes into 5 one time, and 5 goes into 30 6 times. So then when I multiply the fraction across, I get 6 times 4, which is 24, over 1, or just 24. So 30 times 5 over 30 times 4 over 5x simplifies down to be 24x. Minus, well, now a similar thing happens here. 30 times 2/3 is really the same thing as saying 30 over 1 times 2/3. And then 3 is in both of these. 3 goes into 1 3 times, 3 goes into 30 10 times. And so I'm left with 10 times 2 is 20 over 1, or just 20. So 30 times 2/3 x is 20x. And I'm writing these out all separately just so that we get the idea. But you could do the simplification in line on the left-hand side of this if you wanted. So 30 times 1/2 is really the same thing as 30 over 1 times a half. And so this simplifies down. Both have a 2 in common. 2 goes into 1. No, 1, 2 goes into 2 one time. 2 goes into 30 15 times. 15 times 1 is 15. 1 times 1 is 1. So our answer is 15 over 1, or just 15. And then 30 times 0 will just remain 0. So the effect of multiplying the entire equation by the LCD, rather than multiplying it by whatever, instead of multiplying each fraction by whatever I needed in order to find a common denominator, if I just say, okay, multiply by the LCD all the way through, what happens is I get an equation with larger number parts, right? The 24 is definitely bigger than 4/5, but the fractions are all gone. So there's no more fractions. And that's what multiplying by the LCD will do. It takes away the fractions. So now I can resort back to my solve equations in the form ax plus b equals c, because realistically, that is all that I am doing. I can collect like terms. 24 minus 24x minus 20x, that is, those are common or like terms, and they simplify to 4x. Then it's minus 15 equals 0. Okay, now I can use the addition principle. I have a minus 15 here on the left-hand side that I want to move. So minus 15 plus 15 is equal to 0 plus 15. Remember that minus 15 and plus 15 cancels out to 0. So I'm left with 4x equals 0 plus 15 is 15. Okay, 4x equals 15. So I'm going to divide both sides by 4. The 4's on the left-hand side cancel, leaving the x like I'm looking for. And then 15 over 4 is an improper fraction, but that's okay for us. We can leave it as an improper fraction for this. Or if we were asked to, we could convert it to a mixed number. If that was necessary, it's what, 3 3/4. Or if we wanted to, we can convert it to a decimal, and it's 3.75. But either way, this is a to me, much simpler, albeit there is a little bit of understanding that's involved, but this really does simplify the process of working with fractions in an equation.